Hi, welcome to the number 12, solving exponential and logarithmic equations. The first thing we want to do with an exponential equation is isolate the base with the variable exponent. So we're going to isolate the 1/2 by dividing by 20. So we get 1/2 to the x over 3 is equal to 1/4. Then we are going to change the base of both sides so that they are the same, if possible. If it's not, then we'll talk about what to do. But in this case, it is possible because 1/2 is to the negative first, and 1/4 is to the negative second. So if you notice here, this is actually 2 to the negative x over 3 equals 2 to the negative second. Since the bases are the same, we can drop them and set the exponents equal to each other. So negative x over 3 is equal to negative 2. Multiply by 3 to get rid of the fraction, actually negative 3. And so it'll make it positive x equals 6. And that is your answer. Now, if it is not possible to get them to be the same base, then take the log or ln of both sides and we'll be able to basically change them to the same base. So, for example, here, I can't get 5 to be 2 to a power, so I'll take the log of both sides. Now remember, our goal is to solve for x, and one of the properties of logarithms is to roll the exponents to the front. So x over 3 times log 2 is equal to log 5. Then we can divide by log 2 to isolate. So we get x over 3 is equal to log 5 divided by log 2. We want to get the 3 by itself. The x by itself. So we multiply both sides by 3. So we get x equals 3 log 5 over log 2. Then remember that one of the properties of logarithms is you can roll the exponent to the front. So that's the same as log of 5 to the third over log 2, which is the same as log of 125 over log of 2. And then remember the change of base formula. It said the log, basically log of the answer is over log of the base. So this would be the same as log base 2 of 125. So now we have a logarithmic equation. We're going to transfer it into an exponential equation in order to solve it. So first, if we have a logarithmic equation with just a log on one side and a number on the other, we translate it into an exponential. We have 3 to the negative second equals x plus 4. Well, 3 to the negative second is 1/9. We get rid of the fractions by multiplying by 9. So when we multiply by 9, here we get 1. Here we get 9x plus 36. Subtract 36. So I get negative 35 equals 9x. And divide by 9. And I get x equals negative 35 over 9. The next equation is a exponential equation, except now it's e. So instead of taking the log of both sides, we'll take the ln. But first, remember, we have to isolate the base with the exponent. So we subtract 5. So we get negative 3e to the negative 2x equals negative 27. Divide by negative 3. So we get e to the negative 2x equals 9. Now we take the log, or in this case the ln of both sides because it's base e. So we're going to use ln since the base is e. So we're going to go ln e to the negative 2x equals ln 9. Remember, the exponent rolls to the front of the log. So we have negative 2x ln e equals ln of 9. Now remember, the ln of e is equal to 1 because notice the base and the answer are the same. So we get negative 2x equals ln of 9, which means that x, we'll go this way, that x is equal to the ln of 9 over negative 2, which is the same as saying negative 1/2 ln 9. And remember, we can condense it by rolling this to the front, which means it's the same as ln of 9 to the negative 1/2. And remember, 9 to the negative 1/2 is the same as 1 over 9, the square root, which is the same as 1/3. So basically, it's the ln of 1/3, which is the same as the ln of 3 to the negative 1st, which is the same as negative ln of 3. And that's your final answer. All right, if you have a logarithmic equation and they have logs on both sides, then you're going to drop the logs and set the expressions equal to each other. So in this case, it's 2x squared minus 5x equals 3 minus 6x because the logs will cancel out. Now this just becomes a quadratic equation in which you bring the x's to one side and set it equal to 0. So it's 2x squared plus x minus 3 equals 0. Now remember, when you factor a quadratic with a number in front, the factors you're looking for the factors of negative 6 in this case that add to positive 1. Well, the factors of negative 6 that add to positive 1 are 3 and negative 2. So it becomes 2x squared plus 3x minus 2x minus 3. So then remember, you group the first and the last. So you get x times 2x plus 3, and then negative 1 times 2x plus 3. And your factors are 2x plus 3 and x minus 1. You set them equal to 0, and you get 2x equals negative 3, x equals negative 3 halves, and x minus 1 equals 0, x equals 1. Now you have to look, because remember, this is the answer to a logarithm, right? And remember, this will have to be greater than 0, because you can't raise a number to a power and get a negative number. So if I put 1 in here, will it make it positive? Well, 2 times 1 is 2, minus 5 gives me negative 3. So 1 will not work when I put it back in. It'll give me log of a negative number. It'll give me log negative 3, and it's impossible to go 10 to the x and get it equal to -3. That's not possible. So whenever you put one of these numbers back into the equation, it must make that positive. -3/2, if you notice, if you put that in, and I'll put it into 1 just to show you. If you notice, -3 minus, well, -5 times -3 is plus 15/2, which means it's -3 plus 7.5, which is 4 1/2. So notice it makes it positive. So that's why -3/2 works. It's not if this answer is negative, it's when if you put it back in, if it makes it positive or negative. All right, the next one, the minus means that you can divide. So you want to condense first. So it becomes log of x over x plus 2 equals 2. Then you want to translate it into an exponential. And remember the base is 10 here. So it's 10 squared equals x over x plus 2. Remember 10 squared is 100. And then you can multiply both sides by x plus 2. So you get 100x plus 200 equals x. You subtract the x. So you get 99. You subtract the 200. 99x equals -200. Divide by 99. And you get x equals -200 over 99. So now you have to see, if I were to substitute this back into one of these two, would it make it positive or negative? Well, it would make this first one negative, so that means it's not a solution. So that means there is no solution to this equation. All right, last but not least, we have this exponential equation. It's 2 to the 3 to the x plus, now the negative means it can go to the bottom of a fraction to be positive, like that. Now, remember we want to get rid of fractions, so we're going to multiply each term by 3 to the x. To get rid of the fraction. When I do that, that goes away. This becomes 2 times 3 to the 2x, because remember when you multiply these, you add the exponents. X plus x is 2x. And then here you have 11 to the 3x. Or sorry, 11 times 3 to the x. Now, if we subtract this and bring it over so that everything's on one side, so you have 2 times 3 to the 2x minus 11 times 3 to the x plus 15 equals 0. Now, if you notice, right now, we have a quadratic situation. Because let's say I substituted and I said let x equal, or actually let's not use x because we're already using x there. Let z equal 3 to the x. Then right now you have 2z squared minus 11z plus 15 equals 0. So it becomes a quadratic equation. Factoring this, the multiply, you get 2 times 15 is 30, so the factors of 30 that add to -11